Okay, here's section 5.6. We're going to do derivatives of inverse trig functions. Now we've done derivatives of sine, we've done derivatives of cosine, tangent, all that good stuff, even cotangent and cosecant and all that. But what if I asked you for the derivative of sine inverse? Or another way of saying that is arc sine. Could you find me the derivative of arc sine? We haven't talked about that yet. So let's first talk about the rules. They look a little bit complicated, but I'm going to try to show you a few tricks that'll help you memorize them. Will they show up? Yes. Okay, so it's important that you memorize these. Kind of like the long way to find the derivative, the limit definition. Is it hard? Is it complicated? Yes. Do you use it very often? Probably not, but will it show up? Yes, and so you need to be able to recognize it, okay? So these things are going to show up. So even though they're kind of complicated and there's a lot going on, it doesn't mean that you just have to go, oh, whatever, I'll just miss that one. They will show up, and they're easy enough to memorize to get you your points on your test. So please make sure that you memorize them, okay? Let's start off with arc sine, okay? If you look at arc sine, the derivative of arc sine, or sine inverse, it means the same thing, is the derivative of u, the derivative of the inside, over the square root of 1 minus u squared. Okay? The nice thing about these is you really only have to memorize 3. If you can memorize what arc sine is, well, arc cosine is just that same thing, but a negative out in front. Okay? So if you can memorize arc sine, you don't necessarily have to memorize arc cosine as well, because it's the same thing just with a negative out in front. Okay? What about arctan? The derivative of tangent inverse, or arctan, is the derivative of u, the derivative of the inside, over 1 plus u squared. 1 plus the inside squared. Okay? If you can memorize arctan, then cotangent inverse is the same thing with just a negative out in front. The last one is arcsecant. The derivative of arcsecant, or inverse secant, is the derivative of u over the absolute value of u times the square root of u squared minus 1. The hardest part here is they all look very similar, right? You've got u's, you've got 1's, you've got u squareds. So how are we going to memorize the 3? Because again, if you can memorize the 3, all you have to do is attach a negative to the other 3, okay? So let's try to memorize the 3 on the left. So how can we remember all of them? Well, they all have the derivative of the inside on the top, okay? The derivative of u is always on the top, okay? So what's the difference after that? 2 of them have square roots. To me, how I remember it is square roots start with a S, and my arc sine starts with an S, and my arc secant starts with an S, but arc tangent doesn't. So he's the only one that doesn't have a square root. Okay? I know it's kind of silly, but it helps. So square roots are the ones with S's. Okay? So that helps you remember which one has square roots and which one doesn't. The other difference is the 2 with the square roots have negative signs. Right? Tangent does not have a square root. It has a plus sign. You can even think of it this way too. A tangent has a t, and doesn't a plus sign also look like a t? So the t goes with the plus sign. Okay? All right. The last difference that helps me is which order the 1 minus u squared goes, or the u squared minus 1, because it does make a difference, right? So this is how I remember that. Sine ends with an n. And an N looks like an upside down U. I know it's a stretch, but bear with me. Sine ends with an N, and it looks like an upside down U. So sine's derivative has that upside down N in the back, because it ends with an N. So if sine ends with an N, then its derivative ends with an upside down N. I don't know. If it helps you, perfect, use it. If you can think of another way to help you remember it, then please do that. But it's important that you memorize these. They are kind of crazy, they are kind of complicated, but they will show up, so it's super important that you know all these different derivative rules. Okay? All right, so now that we know these rules, let's go ahead and do a few problems. What if I ask you to do this problem? The derivative of arc sine 2x. Okay? So let's first talk about what our inside is. Okay, our inside is here, is this 2x. So this is our u. And when we're doing arc sine, arc, cosine, arc, secant, any of the inverse trig things, we need u's. We also need u squareds, right? So if u is 2x, then what is u squared? Isn't it 4x squared, because you're squaring the 2 and you're squaring the x? Okay? We also need the derivative of u. So the derivative of 2x is 2. So can we use these pieces to put them into our derivative formula? So the derivative of arc sine, remember, is the derivative of u, which is 2. And it's a sine, so it's a square root. It's also a sine, so it ends with an n, so it ends with an upside down. So this is a 1 minus u squared. So u is 2x, so 2x squared is my 4x squared. Right? You can put the parentheses if you want to. You don't have to. You can write this just like this, and this would be my derivative. That's it. You can't simplify it any farther, so that's it. Okay? Let's do a tangent one. I have an arc tangent. Okay? U is 3x. U, derivative of u is 3. U squared, if we need it, is 9x squared. Let's put all of our pieces together. So now we just have to memorize the derivative of our tangent. Tangent doesn't start with an s, so I don't have a square root. But I do have the derivative of u on the top, which is 3. It's a plus sign in between, right? Because tangent has a t and it looks like a plus sign. So on the bottom here, it doesn't technically matter which order you put it in, okay? I'm going to put the 1 first, and I'm going to put the u squared in the back. U squared, we said, was 9x squared. So that would be my answer for my derivative of arctangent of 3x. Okay? Let's do another one. The derivative of arc sine of x square root of x. Normally, we like to change this around. Don't we like to call this x to the 1/2? That's what I'm going to do. I'm going to call u x to the 1/2. That means the derivative of that would be 1/2 x to the negative 1/2. And that squared, u squared, would be what? If I take this and I square it, what happens with the square and the 1/2? Don't they multiply and kind of cancel each other out? So I end up getting just an x, right? All right, let's do arc sine. Do you remember the rule? The derivative on the top. Sine is a square root. Sine ends with an n, so an upside down u. And u squared, we said, was x, okay? All right, this kind of looks weird, though. I don't like this for a few reasons. One, we don't have a triple layer fraction. 1, 2, 3 things, right? We also don't have negative exponents. So let's kind of simplify this a little bit and make this look a little bit nicer. I'm going to keep the 1 on top. I'm going to bring the 2 down to the bottom. I'm also going to bring this down to the bottom and make it 2x to the positive 1/2. And go like that. Okay? This 1/2 exponent, isn't this technically a square root of x times 1 minus x? And in your book, what they do is they take the insides and they multiply them together. So your book will actually write this 1 over 2 times the square root of x minus x squared. So you could write it either way. You could write it like this, you could write it like this. I just need you to know that if it were a multiple choice question, and then if they have it written the way the book does, could you convert it? Okay, but either way would be okay with me. Right? Let's do 2 more. Okay. Let's do an arc secant. Ooh, and we also have a little exponential in there, right? So the derivative of inverse secant e to the 2x. So what is u? U is e to the 2x. So what is the derivative of e to the 2x? Remember, it's e to the 2x times the derivative of 2x, which is 2, so 2e to the 2x. Okay, and what about u squared? If I were to square this, what would happen? Remember, I would multiply and I would get e to the 4x. All right, so let's put it all together. The derivative of u is 2e to the 2x. This is a secant, right? This is a secant, so I should have a square root. Remember, secant is another one that is a little bit different. It has that absolute value of u in the front. Don't forget about that guy. And then I have underneath, does the U go first or does the U go second? That's not a sign, so it doesn't go in the back, it must go in the front. And what was my U squared? E to the 4x minus 1. All right, exponentials are always going to be positive. So can I take this e to the 2x from the top and this e to the 2x from the bottom, as long as that one's going to be positive, right? And I can reduce them. I have no plus or minus sign connecting, so can I reduce off an e to the 2x on top and bottom? So I'm left with the derivative of 2 over the square root of e to the 4x minus 1. That would be my derivative of arcsecant of e to the 2x. Okay? All right, the more you practice them, the easier it'll be to memorize and stuff like that. Let's do one more that's a little bit more complicated. They're asking us to differentiate, and it gives us a little bit more stuff going on, a couple more terms here. Let's do the derivative of arc sine, and then we can do the derivative of this. Then we could just piece it together with a plus sign, right? As long as they're separated by plus or minus signs, I can do each term separately. So what is the derivative of arc sine x? Let's do this piece first. The derivative of arc sine is the derivative of u. So what's my u in this problem? X. So the derivative of x is 1. Sine is a s, so it's a square root. U squared is in the back, so x squared is back here, or 1's back there, like that. You okay with that? All right, plus. Now I'm going to do the derivative of this second piece. The second piece, if you want to rewrite it, is this, is x times 1 minus x squared to the 1/2. Now how do I find the derivative of all this stuff? Be careful. It's a product rule, right? It's a product rule with a chain rule in it. Do not just take the derivative of x and the derivative of the second piece and smush it together. Please make sure you do a product rule. So I have second times the derivative of the first plus the first times the derivative of the second, which is a chain rule. Bring the exponent up, keep the inside the same, subtract 1 from the exponent, and don't forget to do the derivative of the inside, which would be what? Negative 2x. All right, now let's go through and go ahead and simplify some stuff, okay? All right, you could change this to fraction exponents if you wanted to, and call this 1 over 1 minus x squared to the 1/2. It might be easier at first because these other guys have 1/2s in them, but it doesn't quite matter. Here, I have a 1 minus x squared to the 1/2 times 1. No denominator, or a 1 denominator if you wanted to. In my third term, I have this 2 and this 2 that can reduce. I have an x and I have a negative x, so really can I make this a negative x squared on the top? And then I'm going to take this piece and bring it down to the bottom to make the exponent. Oh, I did it again. To make this exponent positive. Now, in order to be able to combine, I need a common denominator, right? I need a common denominator. This guy has a 1 minus x squared to the 1/2. This guy has a 1 minus x squared to the 1/2. So what does this guy need? He needs a 1 minus x squared to the 1/2 on top and on bottom. All right, last thing, let's put them all together. You ready? Here I have a 1. Here I have a 1 minus x squared to the 1/2 times 1 minus x squared to the 1/2, which really gives me 1 minus x squared to the first. You have another minus x squared back here, all over your common denominator of 1 minus x squared to the 1/2. I have a few like terms on the top that I can combine. I have a negative 2x squared plus 2 over 1 minus x squared to the 1/2. Now, I didn't leave it like that. Anybody see anything I can do to the top? If I wrote it in a different order, maybe it would be a little bit more clear if I wrote it like this. couldn't I take out a GCF of a 2 on top? And what would that leave me with? Wouldn't that leave me with a 1 minus x squared? And what do you notice on the top and the bottom? Don't they both have a 1 minus x squared on top and on bottom? Now this one only has a half, and this one has 1. But couldn't I reduce each of them by at least a half? I can reduce a half down here, and I can reduce a half on the top. So what would that leave me on the top? That would leave the 2 there, and that would leave me with a 1 minus x squared to the what? Wouldn't it be a half? If I started with 1 and I reduced it by half, wouldn't there be a half left? Nothing left on the bottom because I reduced it, right? So you could say your final answer for this big old derivative would be 2 times the square root of 1 minus x squared. Woo! Inverse trig derivatives, okay? Not too bad. You just have to memorize the different formulas and the different rules. So if you can come up with a little silly way of helping you guys remember it, then please do that. If it helps, why not, right? All right. So your homework for 5.6 is going to be page 378. It's going to be numbers 41 through 59 on. Okay? All right. I'll see you guys later.